Hi everyone, I am Harsha Buddana and I'm with my teammate Roshan Shah. We are here to present our final project, text summarization using different various NLP libraries. So for the first increment, we did text summarization and question and answering as well with BERT model, and then we thought of to initially do compare it with Distilbert. We tried to process the model with Distilbert, but the accuracy was almost similar and it was using almost the same resources. So we dropped the idea and then we fell back to LSTM. So for the final part of the increment of this project, we did text summarization using LSTM. So this is how the implementation goes. First, we imported all the required libraries for the project, and then actually the data set it was huge enough. So we actually uploaded that data set to the cloud, Google Drive, and then we just mounted the Google Drive to get our data set. So this is the basic info of the data what we have. Mm, mm. This is the title and abstract of the papers. So as we see, the data is not at all clean. So we applied some basic text pre-processing by actually just removing the null values, both from the title and abstract. Then we went forward to visualize the data to see what are the most used words. Using word cloud, we visualize the data set, and these are the most occurring words in titles, and then these are the most occurring words in abstracts. Then we went on to clean the data. We removed all the uh, stop words, and then we went on to clean the tokens as well. Then what we did is to completely clean the data and print out the cleaned data of abstracts here. And then we went on to print the clean data of titles. So after this, we checked what are the word counts of both abstract and titles. And then we set what is the maximum text length, maximum summary length that can be outputted to the outputted from the model. And then we imported the try and test split to split the data set into halves, into two parts. One is training data set and next one is testing data set. From here on, my teammate Roshan will take on.
Hi, I'm Roshan, and remaining part I will continue from here. And here, from after the splitting the data set for the training and testing, we tokenize the data set. First, we will tokenize for the training, and we also count the rare frequency, or we can say like rare words in our vocabulary of the training parts, and we get 62% and 3.72 of the total coverage of the whole data set of the rare words. Then same again, we make the sequence padding for the tokenizations, which is like a simple array for the characters. And we do the same for the testing data set, which is here for YTR is the test validation or testing. And we get 84% of rare words and total coverage is 1954. This is so high for the rare words in the validation part. So this will be the more difficult for the model to predict. Then again, we fit our data set, validation data set in the tokenizations and set to the maximum length for every validation and the training parts. And for all of those, we get like 7,921 for tokenizations, or you can say the training data sets. Then we use the NLP models, which is our LSTM we are using in this code, and we apply the attention layer for the embedding part, we can the decoder part of the LSTM in the last. So this is the attention layer for the LSTM, and this layer we took from Bandhu attention, which is take from the GitHub. Like this is not our attention model. And then we develop a model for the LSTM. We take 3 hidden layer for the LSTM, and as you see, like in the last of the embedding, we take the attention layer, that is here you can see, and we take activation function for the softmax. You can also take the ReLU. I try for the ReLU, but we get the lower accuracy, so I again change to softmax. And this is the model, LSTM model we are used, and we get 200 no, you can say 211,000 for the trainable parameters for our LSTM model. Then we use the optimizer RSPM, and we also use the space categorical category to change one vector. Then we set an early stop, like we set the epochs for the 100 or 200. If the validation loss is like remains constant for the some period, then we will stop the training and get the predictions. So we set the epochs 15 and we set the batch size 28. Here batch size means like for the one input it will take like 128 sets, you can say the data points. So I got the training and it stops at the epochs 25. So we can see the validation loss is like similar. From the 24 it's like the 4949. It's a similar for this one. So it stops like earlier stopping, as I say before. Then we plot the validation loss and the training loss. You can see the plot of yellow indicates the testing and the blue indicates the training. Then for the prediction, we use the reference, or you can say inference, or sequence to sequence to encode the to decode the LSTM part. So use the sequence to sequence here to summarize the predictions. And for the predictions, we can see here like we get the list of the predictor and title, so we can save our predictions in the CSV file or any other files. Here you can see like the original title is longitudinal analysis relationship housing insecurity physical health among aging adults in United States, and we get mental health COVID pandemic adults. This prediction title is based on the abstract models. So I get like 100 predictions, and on the basis of this we get the ROA score. And for the row score, here you can see like I found the row score like row 1 which is for the unigram, row 2 which is for the bigram, and row L which is for the maximum sequence length. And we get better F1 score for the row 1, which means for the unigram. So we can see our model is predicting well for the row 1, and this is F1 score highest is the 13%. And then we save our data set in the CSV file, which I also upload in the Canvas. And we did the PPT for our presentations, and we also did the report. This one is the report for our increment 2. So I did all of this here. Take it forward. I just received my order.
Oh yeah.